Everyone, and good morning, everyone. Welcome to the session related to smart port. This session is divided in three subsections. This is the first subsection with four presentations. Respect to the original program, we have a little change because the paper presented by Francesco Russo and Giuseppe Musolino move from the position number 3 to position number 1. The other speaker about the other three presentations are present too, so we can start. Remember that I ask you to present in no more than 12 minutes for give to the floor 3 minutes for one or two questions. So first presentation is from Francesco Russo and Giuseppe Musolino. The presentation is entitled Case Studies and Theoretical Approach in Port Competition and Cooperation. And present Giuseppe Musolino. Please, the floor is yours.
Thank you, Gianfranco. Good morning to everybody. Could you see my slides?
Yes, I can. Okay.
I am in presentation mode, but unfortunately it does not work. However, this work is co-authored with Professor Francesco Russo. We are both from Università Mediterranea di Reggio Calabria, Italy. And the work deals about the process of competition and cooperation among port system, among commercial ports that is still ongoing in these years. And we will see some elements, some observed elements and elements of classification, and some element related to the modeling, how to model this process. As introduction, there are some drivers.
Sorry, Pepe. The slide is still the first slide with the. I don't know if you are.
No, I'm moving on.
No. We see the first slide.
I try to go again.
Okay, and go on.
Yes, I'm doing. No. Can you see the next slide?
No, the presentation. Moving.
Do you see the second slide?
I can send you my presentation.
Yes, of course.
Okay.
No. Okay. Slide, yes. Now the second slide. Try the third slide.
You can see.
Yes.
Now it
Okay.
It works.
Okay.
So
okay. Continue.
So I was. Let's start again. There are, as I said, there are some drivers that guide this cooperation and competition process among ports. And there are the three main are the process of consolidation in carriers alliance, the growing ship dimensions that require deeper channels and berth, and then the joint enhancement of interland access. ports in proximity share terrestrial infrastructures in order to limit their investments, and also optimize infrastructures and common infrastructures and services. I don't go into the detail about the what happened in Carrier Alliance. We can talk at the end if there are any questions, nor in the detail of increasing ship dimensions. That has a great emphasis in the container sector. I just recall the conceptual background of this work that lies in the definition of fourth generation port by UNCTAD, given by UNCTAD in 1999, that states that ports are physically separated but linked through common operators or through a common administration. According to this first embryonal definition, there was a rich literature about this definition, together with the ongoing process that started among ports due to the globalization process. So the research question or two, the first concerned the possibility to build a theoretical model that allows to study the competition cooperation process between ports in the behalf of this definition of fourth generation port. And then the second, observe our ports all over the world or responding to these drivers that I mentioned before. So the presentation is articulated in three parts. Some first elements about the theoretical approach we are working on. The second part, some representative case studies of this competition process. The word competition merge the two words competition and cooperation, and some final remarks and future work. The theoretical background lies on the transport system modeling approach. And we have, according which the transport system is subdivided in a supply element, which is the port system, and the demand, which is the behavior of shipping alliance. And then, according to the TSM approach, there are three modeling elements: the supply model, the demand model, and the demand-supply interaction model based on equilibrium assignment model. These modeling elements are well consolidated in the literature concerning the modelization of urban terrestrial network at urban and higher level. So the attempt is to transfer this body of modeling body in the port environment. So some combination of cases could arise. There are competition against cooperation behavior between ports that could collaborate by means of different level of cooperation. And the situation can be congested or non-congested. As far as concerns the equilibrium model, we rely on two concepts, two consolidated modeling concepts. The concept of user equilibrium approach that we associated to a competition attitude of ports. And then we states this definition in brief terms that an user, which is the alliance of the MTO, chooses deterministically a terminal or a port that allows minimizing his individual cost. The other theoretical approach is the approach of system optimum that we could be associated, according to us, to a cooperation behavior. We know that according to this approach, an user chooses an alternative in order to let achieving the minimum total cost for all users, although some of them choose non-minimum cost alternatives. So these are the theoretical background of the models that we are still working on. Then we go to the second section, and we looked at some case studies all over the world where the competition process still is working on. And we classified the three types. We considered three types of cooperation among ports: the merger process among port governance, in order to have a single entity, governance entity. And then there is the alliance. Another form of cooperation is the alliance on one or multiple demand segment. The leading segment is the container. And then the third type of cooperation is based on commonly supplied projects. The ports share a supply, an infrastructural project. We can see some representative example. For example, in the case of merger, we have the example of the Italian ports, where there was a reform in 2015 that allowed to reduce and to introduce the concept of port authorities. There was a long path before completing this reform that was finally completed in 2021 with the designation of the president of Port Authority of Gioia Tauro. However, as we know, as the Italian people know, there were some elements that were considered during this process of aggregation. And then we arrived to a final asset of Italian port authorities that we can see in this figure. The other representative example of the alliance is the Copenhagen-Malmo alliance that lead to one port authority, a single port authority, and it was a pioneering process that led in the 2001 to the first binational port in Europe. I don't go into the detail, you can see in the paper. And then on a single market element, especially the container, we can consider some example all over the world. In America, we selected, among the other, the Seattle and Tacoma, and then in the Far East, Kobe and Osaka, and Ningbo and Busan, where there is a great aggregation process in the area, also with the Shanghai port system, that will lead to catchment area of 100 million of population. The last case that we consider is the Los Angeles and Long Beach cooperation that started on the base of a big infrastructural project, a great regional railroad project.
Okay, 2 minutes more,
Yes.
Pepe.
Going towards the conclusion, we looked at these case studies, and there are some lesson learned. So there is a merger. There is some ports merge their public governance into single entity in order to push new and coherent goals. There are the alliance type that can be based on multiple market segments and one market segment, especially in the container sector that is the more dynamic. This driven by gigantism alliance and sea land integration. And then there are some elements. The third category consider the case of a creation of an infrastructure of common interest for the two ports, which is the weakest form of alliance. This element, according to us, could allow to actualize the fourth generation port, considering two categories of cooperation: the vertical cooperation of ports and the horizontal cooperation among ports. And at the end, we can say that we are working on the application, the specification and application of the transport system modeling on the port context. And we think that it is possible to extend the consolidated quantitative methods into the field of maritime and transport ports in order to simulate and interpret this competition process that is one of the main elements that is observing in this period. We are also working on other elements, of course, that I recall the main two elements. The first concern how the emerging ICT could support virtual horizontal and vertical integration in order to increase cooperation among port stakeholders and solve interaction in port flows. This is another line of the research, and another one concerns the green and the resilient ports. In particular, how the concept of risk could be declined also in the case of ports and in general in the case of the supply chain. Thank you for your attention.
Okay, thank you, Pepe, for your nice and very interesting presentation. We have time for a quick question from the floor. No, just from me. In your experience, speaking about cooperation between ports, for you, the problem are technical and administrative problem or political problem? Which area give more problem to create a stronger cooperation between ports?
According to me, there is a mix of problems. As we can could see, by looking at the different experience, and this is there are political problem in order to share the governance among single ports. And this, for example, this one of these elements was observed in Italy. We know that the first proposal of port authorities in Italy propose a more aggregation level. And then the final asset was finally the final result of a negotiation between the central
authority, ministry authority,
the ministry and the municipalities, because the ports, we know that the ports are strictly connected with the municipalities, the near municipalities. So this should be like a synthesis of a negotiation.
Okay.
And also could be also technical element how to share and also plan common infrastructures, both on the seaside and especially also in the land side.
Okay, thank you, Pepper. Thank you for your answer too. Okay, we can move to the second presentation from a research group of University of Catania, Nadia Giuffrida, Martina Fazio, Giuseppe Inturri, and Matteo Ignaccolo. The presentation, the paper is entitled Fostering Ports Synergies by Centrality Measures, an approach based on automated identification system. Nadia, okay, present Nadia Giuffrida. 12 minutes, and please, the floor is yours.
Thank you. Good morning, everybody. Can you see my presentation?
Yeah.
Okay, perfect. Thank you. Good morning, everybody. I am Nadia Giuffrida. I'm currently a postdoc researcher at the University College Dublin, and today I will present this study which I performed together with my colleagues from the University of Catania, Martina Fazio, Professor Giuseppe Inturri, and Professor Matteo Ignaccolo. And I will talk you today about the possibility to create new synergies between different ports, basing on the so-called automated identification systems. Last year, we saw the accident of the blockage of the Suez Canal, which showed us the importance of maritime transport nodes, even when they are not origins or destinations, but only just crossing spots for the ships. So it's very important to have a reliable system and a real-time system for monitoring the vessel's movement and position. And another consideration that we always do by looking at ports is that it's very important to foster the synergies between ports and urban areas and administration. And we also saw it for the previous presentation that this can play a key role, a very important role for the sustainable development of the whole cities. So the aim of these studies is to understand the importance of a port as a node within a global maritime transport network, also regardless of the amount of the ended traffic, but just taking into account the ship's movement and their main origins, destinations, and stop positions. The aim is to propose also potential cooperation policies between different ports. And the method that we will use is an approach that will analyze the centrality of the ports based on the port calls detected by the automatic identification systems for maritime transport. This is a global framework of the whole methodology. So the first thing will be that we will take into account the automatic identification system data on vessel positioning. In particular, we will focus on the port calls, which are the departures and arrivals of ships at ports. And then starting from this data, we will evaluate the so-called centrality measures. The automatic identification services are tracking systems that use transceivers on ships, so radars and GPS, to locate the current position of vessels, and it is used by the so-called vessel traffic services, which are online services that show the current position of ships. There are two main types of information: the real-time position of the vessels located on a map, and also the so-called port calls, which are arrivals and departures. The AIS service generally displays the information related to the name of the vessel, the type of traffic that is handled, departure and arrival time, and also it can also display other information such as the deadweight tonnage, the size of the build of the ship, the year built, but it depends on the different services because there are a lot. You can find a lot on the internet. Here in the screenshot, you can see an example from a free online service which provides the real-time information on vessels' positions and port calls, and it's the Vessel Finder website. Starting from this port calls, in our methodology, we moved all data to an Excel spreadsheet, and then we used a network software to evaluate the centrality measure. The software that we used is called Gephi. It's a free and open source software for visualization and analysis of graphs and networks. We will use it to visualize the topology of the network and also to calculate the centrality indices. The main components that we will use in this Gephi software are nodes and edges. So it's like a normal network that we can see in transportation softwares. About the nodes, we have an identification code, a label, which can be, for example, in our case, the name of the port. And it's also an optional to have the geographic coordinates of the port because the Gephi software has a plugin which is called the GeoLayout, which allows a geographical representation of the nodes. Here, for example, in this case, you can see that this one is Sicily, and here there are all the Sicilian ports located here with all the links to the other ports which are linked to the Sicilian one. And in the ages table, we have we know the name of the source node, which is the origin node, so the port of origin, the target node, the destination port, and the type of link which might be directed or undirected. For example, in our study, we will have directed connection because we know which port is the origin and which one is the destination. We evaluated 4 different centrality indices. We have the first one, which is the degree. The degree is the number of links, the number of edges which is incident upon a node. We have 2 types of degrees: the in degree, so the number of incoming links, and the out degree, the number of outgoing links. A high in degree, for example, means for a port that it's a frequent destination. So a high out degree means that it's a frequent origin. Then we evaluated the closeness centrality, which is the average length of the shortest path between the node and all the other nodes in the network. And the more central is a node, the closer it's to other nodes. And this, for the ports, might show the directness of links between the ports in the network. Then we have the betweenness centrality, which evaluates the times a node lies on the shortest path between other nodes. For the ports, this can be considered a measure for a port to act as a bridge, so a stopping point between origins and destinations. And finally, we have the eccentricity, which is the inverse of the distance of the farthest node. And higher value of eccentricity means high node proximity. So the eccentricity might be considered as a measure of coverage of the port network. Our case study in particular is the free port system authorities in Sicily. As already said in the presentation that was made before, since 2016, In Italy, we have the new so-called port system authorities. So the older port authorities have been grouped in order to promote synergies of operations between neighboring nodes and neighboring ports, with the final aim to increase the overall competitiveness of the whole Italian ports. In Sicily, we have 3 port system authorities, which are Eastern Sicily System, which includes the Port of Augusta and Catania, Western Sicily System, that includes the ports of Palermo, Termini Imerese, Trapani, and Porto Empedocle, and the Strait System, which includes the Sicilian ports of Messina and Milazzo, and also the Calabrian ports of Villa San Giovanni and Reggio Calabria, which will not be taken into consideration in the study. Here, a brief description of the ports. In the Eastern Sicily Sea, we have the Port of Catania, which is mainly a commercial port for ro-ro traffic. This is due to the central position with respect of the metropolitan area of Catania and its proximity to all the logistic areas of the Eastern Sicily. The Port of Augusta is part of the 10T core European network, and it's a very important industrial port serving the petrochemical center located in the closest city, which is Syracuse. And it's also an important naval base of the Italian Navy. But new spaces are going to be dedicated also to commercial trade, so road traffic and container traffic. Port of Messina and Milazzo are mainly passenger ports. The Port of Messina is the gateway of Sicily to the Italian peninsula, so it has a very high record of passenger and ro-ro traffic, while the Port of Milazzo, its main connection are to the Aeolic island, but there is also a big freight traffic of liquid bulk due to a petroleum plant located very close to the port. And for the Western Sicilian Sea, the Port of Palermo is a passenger port and port for containers, but one of the main perspective for this port is to move the container traffic to the port of Termini Imerese, which have very large spaces to be used. The port of Trapani has a lot of connection with the Egadi Island and Pantelleria, and it also has historical connection with North Africa, in particular with Tunisia. And finally, the Port of Porto Empedocle has an history for being a hub for trading salt and sulfur, but currently it carries out mainly recreational activities. For our study, what we've done is that we manually acquired the data from an online provider of ship tracking services. We used 2 weeks of data for this experiment from the 23rd of July to the 6th of August of the 2020. Of course, this data were influenced by the pandemic restriction, even if it was the period with less restrictions. So we decided to take into account only the port calls related to freight traffic.
Nadia,
yes.
2 minutes.
Okay. We decided to exclude the traffic of liquid bulk because the figure of the Port Augusta were not comparable to the other ports. And we also excluded, we didn't find any exclusive freight traffic for Messina, but only a combination of raw packs. So we also excluded this data. So finally, we used 7 ports and the free traffic categories. And we included the entire route of each port call, so from the port of origin, including the intermediate stops, to the port of destination. This is the final result for the topology of the network that we obtained. The GEFI also allows you to export the network in the KML type of file, so we can use it on the Google Maps to see the real location, and we can see it on a map. What we can see from the map is that Sicily, of course, has connection mainly with Italian ports, but also with the East and South Mediterranean, even if the ports usually are just for stopping points for higher routes. This is the results that we obtained for the Centrality Index for the global traffic. So the Port of Catania has the main degree, so it's the main port used for origin and destination, while the Port of Augusta has the higher betweenness, so it's the port which is mostly used as a bridge. And then we have some ports which have higher values of eccentricity and closeness, but these values are quite similar among all the other ports. We also differentiated the traffic in solid bulk, container, and ro-ro. Catania has the main role for the ro-ro part, while Trapani has the main centrality indexes for the containers, and Augusta the main for solid bulk. It must be highlighted that this value doesn't mean that these ports also have the higher traffic in these categories. It's interesting, for example, to notice that Catania still has the higher traffic, but it's very, very close to the one of Palermo. So Catania, while having the same traffic, has higher centrality indexes. The same happens for the other types of traffic. So what we can see from this analysis is that there is a clear differentiation in the types of traffic handled in the port terminals, because we obtained very different results for the global traffic and the single one. The port authority system of the Eastern Sicily could concentrate its activity for ro-ro traffic, and a share could be directed to the port of Augusta. Western Sicily Sea could concentrate increasing container traffic, in particular in Trapani and Termini Imerese, and the port of the Straits could keep the transit vocation to connect Sicily to the Italian peninsula. Of course, the future of the industrial ports of the Augusta and Milazzo is the more uncertain, because one day, sooner or later, they will have to change their final destinations, and they will have to decide the way the current industrial plants will use it to renovate the ports. The main limitations of the study, of course, is that the data were collected during the pandemic, and the future trends will be significantly different from the ones that we saw in this data. We made this analysis only for Sicilian region, but of course, the network is bigger and the analysis could be performed at Italian level, but also in a global framework at European level, or even at a global international level. Thank you very much for your attention. That's all. And if you have any questions, feel free to ask it.
Okay. Thank you, Nadia. Nice, very nice presentation. Any question from the floor? No, I have just.
There is Francesco Russo.
Okay. Professor Russo.
Thanks.
Yeah.
I would like just to pose two questions. The first question is more general respect to the methodology. And the second one is more specified for the different ports that you consider. The first one is if you consider in your study the possibility to use the network analysis not for each port considered standalone, but for the set of group of ports that stay inside the port system authority. And then we have just one note, just one specification for each authority, and then compare the different authority with the full trade of the 2 or 3 ports that stay inside. This is the first consideration. The second one is if you, but this is in line with the previous presentation that give Peppe Musolino, if you consider the synergy inside the port, and then if you modify the cost moving from one approach to another approach, and then moving from classical user equilibrium to optimization. The third one, but is very linked with the first one, is if you have, because I just for a moment look at your table specific with the specific number for each port. If you consider the very different quantity of trade that you have between, for example, the Strait Authority and Augusta Authority, because the Strait Authority is quite, how do you say, a game authority is not very authority, because there is not a first level port. Any of the port is first level, is just a passenger port without very traffic, very freight, and so on. And then I think that the very authority of the port in Sicily is just Augusta, because it's the only one port of a first level at European level. Then this is the three different considerations. Thanks for your presentation. That was very interesting.
Okay, thank you very much for your questions.
Very quickly, Nadia.
Yes.
Because we are.
And for the first question, we at the beginning we tried, as you said, to compare the three different port authorities, but as you said, in the end, it's more difficult for just three authorities located inside the same island to make this type of comparisons, because currently the ports still have very, very different traffic. They are not very specialized. So in the end, we decided that since there were just few differences if comparing the single authorities, we decided to compare the different ports, just an exercise to see if the method was reliable, how it worked, if the software was the one which was good to make this type of comparison. But an analysis of different, including the different port authorities, I think that it will be more convenient if we take into account all Italian territory, for example. If we take into account all Italian territory, maybe we can compare all the port system authorities, because there are very different specializations, and we can compare the global traffic. We can compare the single traffic by each port, and the results will be more interesting. For the third question, I totally agree with what you said, and of course, as I said, our data was influenced by the pandemic. For example, the port of Augusta had a very big betweenness, because a lot of ships during the pandemic went to stop in the port of Augusta and was staying there. So maybe also other type of traffic were taken into account in this analysis, even if they are not usually traffic located in the port of Augusta. Okay, so I believe this study, the real results are a little biased by the origin of the data, and that's also why we decided to take into account only 2 weeks, so it can be considered more like an exercise that should be broadened in the future with new data, with automated collected data, and with a bigger amount of data in order to see the real specialization on the ports.
Okay, thank you, Nadia. Please, help me to maintain the organization. You can discuss in after or by email or as you want, but I needed to continue. Okay, thank you, Nadia, also for thank you, Professor Russo, for the question, and Nadia for the answer. The third presentation, we have 15 minutes of delay, is from a group of Università La Sapienza in Rome, from Stefano Ricci, Vinicius Das Chagas, Maria Eugenia Lopez, Cristiano Marinacci, and Luca Rizzetto. The title is Dimensioning of a Container Terminal, Validation and Application Fields for a Stochastic Process. I suppose that Stefano Ricci presented, no? Stefano?
Yes.
Yes.
Can you hear me?
Yes.
Okay, I can try to share my screen.
Okay. You have 12 minutes.
Let me. Oh, can you see the screen?
Yeah, not in presentation modality, but
now I try to change. Okay. Now it's better.
No, the same.
The same.
But you can use this because it's
you see the switch to
no, number one. Now the slide is the number one.
But if I move to second and third, you can see that, or it's the same?
No, not the same.
Okay, so a moment, because it's something that happens frequently. So, okay, now you are in normal mode, but it's okay.
Okay.
I enlarge a little bit this mode, and we check.
It's okay.
It's okay.
Try to go to the second.
Try to go to the second. It's okay.
Okay, perfect.
Okay, we follow this way because it's easier.
Okay, go.
Okay, to be short, it's difficult because we have many authors, but the authors you already listed, so I don't repeat. It's an international collaboration, our group in Rome, and one person from Brazil and one from Spain. Topic is dimensioning of container terminals, and this is the extension and the validation of a method that we already developed in the past, stochastic method for that. Okay, the introductory context is very general, but what is very important that we are to face in the terminal both hard components and soft components, so equipment and stacking facilities on one side, and the other side storage and loading information systems that are managing all traffic inside the port, and with a lot of external constraints, including scheduling of ships, trains, trucks, and other related systems. The objectives of this work in particular, but in general of this approach for the preliminary dimensioning of terminals is that to give effectiveness and robustness both to handling process, the design, because the design is one potential use of this method, and also support key decision when you have to decide about potential solutions, alternative solutions that you can have in a terminal. So the proposed approach, basing on this introduction, is stochastic methods that it's trained by data from already operated terminals. So it's the idea is to starting from is a typical bottom-up approach from what is already working and existing to the extension to other situations, future situations. Okay, so we have a lot of applications, similar methods in the literature, both for containers but also for bulk terminals. Obviously, the first conceptual step is a selection of key parameters for describing the terminal operation. There are many different solutions. There is here a list, but is just an example that we have used in a previous study. But this is something that should be decided when you start to work in this direction for the implementation of the method. So. Idea is that you can use this method in two typical working situations. One is when you have to support the preliminary design itself. So you have to decide the dimensions, equipment, and obviously it's a preliminary level of dimensioning that should be later on more focused and more detailed with more specific analysis of single sub-terminals, single operational areas. But it is important to have already general information and clear view of how big should be the terminal and which equipment should be necessary. On the other side, it could also be used the method for when you have already a terminal in operation, you want to quantify in more precise way the achievable performances in terms of traffic that you can handle in specific time. So in general, when the approach that is used is starting from survey on operator terminals, decide obviously this survey should be focused on a specific sampling area or according to sampling criteria that should ensure quality of the results. In our approach, but it's not the only one existing, but is our proposal for this work here is to have three families of parameters. One is about dimensions, examples are K length, stacking areas, and so on. The second point is the equipment, obviously. So in this specific case, we have gantry, storage, and other cranes and loaders, not cranes, but mobile loaders, and production indicators in terms of traffic, handle containers, TEUs, and container tonnage that are similar indicators, but not obviously completely corresponding. Okay, state of the art is an old application of similar systems in 1985, so very old one. In the literature is available. And 2008, it was from our group. Because our group is very old, not only myself, but myself particularly. And that is start from the looking for a correlation among these parameters after they have been collected from the existing terminal, and then after that to apply a stochastic analysis based on the very normal and consolidated methodology for looking for a certain reliability of the results that you are going to use. In particular, here we have start from the state of the art, but we have developed two main extensions and updates. One is integration of previous surveys from that was mainly from the previous literature, mainly based on Europe, and also thanks to our international authors, co-authors, also a geographical extension to Latin America and Caribbean. So the available data source at the beginning were obviously the commercial public database and websites, Marine Traffic, Fleetmon, sea rates, and then after that we have analyze the institutional and economic organization data sets, and also put in place a specific survey with questionnaire in English, Portuguese, and Spanish, addressing more than 200 port authorities and terminal operators. So it is ongoing because it's a very long process, because it started in 2019. We receive, obviously we collected many data from other sources, but this specific survey has been implemented and is ongoing. Sometime we receive some results after 1.5 years. Okay, in total, the global data collection related with 2019, it was in Europe a total of 208 terminals in 34 countries. It's a very large extension, and Latin America and Caribbean is about 112 terminals within 17 countries. So it's a good coverage, I think. Here there is the table in which is represented the single parameter availability, because obviously not all terminals provide all data on all parameters. So this is the situation that you can have. The largest is obviously query length. It's very simple data to have. For other, it's more complicated and less reliable sometimes. Okay, there is also the matrix with the combination of parameters for statistical analysis. Here there are the linear regression correlation coefficients between parameters. Okay, I don't want to enter into more details about this, but just to give you the process, I think that also this overview it's useful. Direct and indirect correlation comparison obviously are possible. When you start for one parameter and you look at another one, you have different paths inside the graph, so you can look at this. And so the approach that we use is to create a graph and to search the shortest path within this, like with a Dijkstra algorithm, similar that is able to, because obviously you start from, I don't know, from the traffic in TEUs and want to calculate how should be your covered stacking area. You can do this in many with the alternative path, but each path is qualified by the quality of the relationships that you have between these parameters from the data that you have collected. So methodology validation has been in two terminals, one in Europe, in Portugal, and one in South America, in Brazil. And so this is for 3 parameters, query length, total stacking area, and number of gantry cranes. The scenarios are 2 typology. One is based on the full sampling of data, so both Europe and Latin and Caribbean, and other are specific. So for Portugal, European dataset, and for Brazil, the South American Caribbean dataset. So some example here, I don't enter into the details, but it's just to say that the deviations, this is obviously a normal validation process, so the comparison between the results that is given by the method and the existing system, equipment, the dimensions, traffic in the terminal that we have used as a validation. So the deviation is not so big for European terminal, and medium fitting also for the Latin American. For total stacking area, a little bit less, so a little bit higher deviations, but I think that anyway I have very good results, about 15% of deviation between the observed situation and the water model set. And the same is with a little bit lower reliability for the gantry cranes, in which the South America situation is a little bit less reliable, also because there are differences in terms of operational scheme and cultural aspects also, if you want. So in general, in the European terminal, we have very reliable results with limited deviation, so it's very, very satisfying, the results. Higher reliability normally are for dimensional parameters, so the geometrical parameters are more reliable, but this also probably easy to understand because it is less affected by operational aspects. And on the other side, in South America example, the results are a little bit less reliable, but more reliable when you use only the dataset of South America. So it seems to be more local, local qualified terminals. So they need really to be use the data sets, the corresponding data sets that is more responding to the operational mode and the scheme that are applied there. But it is something to be discussed, and it's interesting. Now we are trying to make other validation on other terminals. So the general validation feedback is that the model is unaffected by the traffic input parameter. So any more or less is similar if you use number of containers, TEUs or tons. Also, if for the handling is not the same. There are this feedback I've already given to you, so the deviation less in Europe and more in Latin America. There is also the problem of the dimension of the terminals, because as I anticipated, there are very, very different terminals included into the data set. So very big hubs and some smaller terminals. So it's something that suggests us also some kind of clusterization in the future of the terminals, both on geographical point of view, from geographical point of view, but also from a dimensional point of view.
Okay, 1 minute.
Okay. No, as I finished. I just had to say that
okay.
What we said, we had achieved our extension of the European database that was already available from the previous study, the last one in 2008. But now we have enlarged, so the database now in Europe is very complete, about 40 countries. So it's including also big area and countries like Russia, Scandinavia, Great Britain, and Balkans. Then in the previous study were not included. In that previous study were based on Mediterranean and North Sea, but now we have included these areas, so it's the coverage is very large. The validation that is new, the confirmation of the ability to reach satisfying reliability for the results. The result is also the increased reliability when you train the method with specific continental data sets, but also on the other side, the idea that is very open methodology and that you can extend. So we have now trying to reason about extends to, for example, environmental and energetic indicators that are very important, and in the future are very, very important for ensuring the sustainability of the ports themselves, and different approach of terminals, because it's in theory we are now bulk are already on the literature. Something could be done also for the cruise terminals, so for passengers. So further geographical extension in the future are necessary, Asia and North America at first, and also the segmentation, as I anticipated, by sites, technological advance that are different in different geographical areas, and it could obviously will improve the quality of the results, I think. Okay, so the questions are welcome, of course. Thank you for your attention from our large group, not only from myself.
Okay, thank you, Stefano, for very nice presentation and nice very interesting issues. We have only 1 minute for a quick question from the floor. No question from me, just curiosity. If in your analysis, do you have considered transshipment terminal regional ports and regional terminals together? In the future, yes. You can think to divide it, to create two different sets, also transshipment regional on public and private management.
This second point we have not yet considered, but thank you for the suggestion. We can try also to reason about this. This is very, very different country by country, because in some countries private that does not exist at all. But okay, it is good for the dimension. Yes, now they are all together, but it is already clear from the results that it's very important to make a clusterization in terms of dimensions. For also, if the two terminals that we use for the validation were both long distance terminals or hubs, because one is nearby Sao Paulo in Brazil, it's a very large one, and also the other one nearby Setúbal in Portugal is very large. So, but okay. This is obviously affecting the results, so should be focused more into details.
No, it's just a suggestion for
yes, of course. So we are already working in this direction. This is the idea, indeed.
Thank you, Stefano. And okay, we move to our last presentation from a group of University of Salerno, from Stefano De Luca, Chiara Fiori, Lucas Cisterna, and Pasquale Argento. The title of the presentation is Greening the Last Mile in Port Cities, Environmental Benefits of Switching from road to railway for the Port of Naples. Lucas Joel Cisternas, the floor is yours. Okay. Try to present, to share the presentation.
Okay. Can you see my presentation?
Yeah, try the presentation modality. Okay.
Okay.
Perfect.
Okay, good morning. See.
Okay, 12 minutes for your presentation.
Okay, thanks. Good morning, everyone. I am Lucas Cisternas. I am PhD candidate from the University of Salerno. I present our study about greening the last mile in port cities, environmental benefits of switching from road to railway to port for the Port of Naples. This is my presentation outline. Firstly, I speak about the motivation and research goals, then the case study and scenario analysis. After that, the methodology applied, and finally, the results and conclusion.
And Lucas, please speak near the microphone because your voice is not very clear. Okay. And with increase the volume.
Okay. The last mile connections is a critical issue of any port system and may significantly affect the efficiency and environmental sustainability of the entire logistic process, especially in urban context. Generally, the last mile of many urban ports is mainly supplied by road transport, with negative effects on the environment, on the urban congestion, and road safety. It is mean of the quality of life of the involved communities. Nowadays, the last mile is assuming an increasing role in attracting new investment and new regulation from the Euro Union, considered a priority in transport planning of the port communities. In this context, the Central Tyrrhenian Sea Port System Authority is planning the construction of a rail freight yard within the port area of Naples, equipped by 5 electrified tracks with 750 meters and 5 electrically driving trains with a capacity of 50 TEUs per train. The research goals were assessment the change of CO2 equivalent emitted in the study area and the consideration for the transport of containerized freight in the new container terminal configuration, identifying different scenarios in which mixed road rail freight transport solutions could replace the current scenarios based only on road transport. The case study is the city of Naples, where the port of Naples directly impacts through the flow of incoming and outgoing road freight demand. The scenario analyzed was considered a possible future development of container terminal and construction of a rail link between the port of Naples and San Giovanni Barrel Station. The project envisages a new railway to serve to Port of Naples, guaranteeing the presence and arrival and departure segment of length of 750 meters. The study was focused on the road arteries of the Port of Naples. The roads considered for the evaluation of the energy consumption are one for road transport with input AB with green line in the picture, and output BA evidence with yellow line in the picture, and one route for rail transport with input and output CD and DC evidence with red line in the picture. The study has been carried out by 50% split between import and export according to available data from the Port Authority, considering two growth scenarios. The first one involved 600,000 TEUs per year, and the second one an increment of 40% of freight demand. For all scenarios, it is assumed that each truck loads 1 TEU and each electric freight train 50 TEUs. And both import and export freight transport is carried out using vehicles moving with a load factor of 1. 4 operational scenarios were analyzed. Scenario 0, or do nothing scenario, that represents the current state of the port. Scenario 1, or realistic regional scenario, which envisages a regional catchment area which only import freight flows interested in rail services. It is also assumed that the maximum freight flow on rail is 75,000 TEUs. Scenario 2, or national scenario, which forces both import and export demand interested only in rail services. And finally, scenario 3, an increase from 5 to 9 trains per day is forced, and therefore demand flow up to a maximum of 135,000 per year by rail. The approach used is the well-to-wheels one, that consists of two sub-analyses. Time-to-wheels analysis, which consider the in-use consumption and emission of the vehicle, and well-to-tank analysis, which take into account the extraction, conversion, and transport processes of the energy carried used. For the estimation of consumption and emission in use in road freight transport, microscopic models now from the literature were adopted, in which specific fuel consumption is calculated as a function of speed profile over time. After that, the CO2 equivalent is calculated through emission factors. This is the polynomial relation adopted, which the values of parameters A, B, and C are given in literature for a large track, and the specific fuel consumption as a function of speed has a trend as shown in the picture. This model has been applied to a real urban cycles in the city of Naples for a realistic estimation of the consumption considering the driving behavior in a real urban environment. On the other hand, the time-to-wheels calculation of train consumption was based on data from the report Railway Handbook Energy Consumption and CO2 Emissions. And finally, for a more extensive analysis, well-to-time emissions were estimated using coefficients available in literature. This picture shows the results of the tons of CO2 equivalent in the well-to-wheels analysis, produced in the 4 scenarios considered in the case of a yearly movement on 600,000 TEUs. Comparing scenario 1, 2, and 3 with do-nothing scenario, the results shows that the scenario 1, shifting 75,000 TEUs from road to rail mode, a reduction of 8.4% in road mode and 6% increase in rain mode as observed. Regarding scenario 2, 150,000 TEUs are shifted to rain mode with a reduction of 25% in road mode and 11.9% increase in rain mode. And finally, in scenario 3, shifting 210,000 TEUs from road mode to rain mode, a reduction of 31.7 in emission associated with road transport in road mode, and a 16.7 increase in emissions associated with rail transport. On the same way, for 1 million TEUs scenarios, comparing the scenarios 1, 2, and 3 with do nothing scenarios, shifting 75,000 TEU of freight transport from road to rail results in a 5% reduction in CO2 equivalents in the road mode and 3.5% increase in the rail mode. Regarding scenario 2, 150,000 TEUs are shifted to rail mode with 15% reduction in emissions from road mode and 7.1% increase in emissions associated with rail mode. And finally, in scenario 3, the shift of 210,000 TEUs to rail mode results in a 19% reduction in emissions associated with road mode and 10% increase in emissions associated with rail transport. It's also noted that the limit of 75,000 TEUs in the proposed configuration for the rail transport produces a limited reduction in global emissions. In particular, in the 1 million TEU scenarios, we can see that the percentage reduction compared to the do nothing scenario is smaller than for the 600,000 TEU scenarios. In conclusion, we can say that the analysis shows that for the same number of TEU handled, rail transport allows a reduction in global CO2 equivalent emission of 50% compared to road transport. And the limit of 75,000 in the proposed configuration for rail transport produces a limited reduction in global emission because the modal shift to rail is limited compared to the total volume of freight to be handled. Thank you for your attention.
Okay, thank you. Thank you, Lucas, for your nice presentation. Just 1 minute for a question from a floor. Curiosity or question? No, just a curiosity from me, from my side. The scenarios you have dimensioned, the scenarios also only in a transportistic way, or you have considered or estimated also a general cost respect to the infrastructure or infrastructural sector, or modify some elements? You have estimated also cost or no?
No, only a transportistic way. Yeah.
Okay. Okay, thank you. Now is finished the first subsection related to smart ports, and now I leave the floor to my colleague Patricia Serra as the chairman for the second subsection on smart port. Okay, thank you very much for your availability. Okay, thanks a lot.
Is on.
Okay. Good morning, everyone. Welcome to the second session of the Smart Ports workshop. My name is Patrizia Serra. I am a researcher at the Department of Civil and Environmental Engineering and Architecture at the University of Cagliari. In this presentation, we will continue discussing smart ports from different perspectives. We have 4 presentations, so one more with respect to the official program. This is good, but it means also that we have to respect time limits. So we have 12 minutes for presentation plus a few minutes for questions and answers. I recommend everyone to respect the time limits. We can start with the first presentation, which is actually by our research group. It is co-authored by me, Professor Gianfranco Fancello, Professor Riccardo Bozzo, and Andrea Zoratti. The study will be presented by me and Professor Gianfranco Fancello. I'll give the floor to Professor Fancello, who will start presenting how to create a cross-border port community by networking ports with each other, the experimentation of the EasyLog system. Gianfranco.
Yeah, okay, thank you, Patrizia. This presentation is presented by me, and Patrizia presented the first 10 slides very quickly. Okay, the research area, the research issues of this presentation is a digital port. A lot of research groups are studying now the digitalization in the port, especially how is possible to create cooperation and information sharing through digitalization inside the port, because this aspect is very crucial for the port operation and for port competition. Moreover, the digitalization of some port process can compensate the lack of physical port infrastructure. As you know, digitalization in the port process have achieved a very high level in the container sector, in container port, but now have a low level in Ro-Ro terminal, in Ro-Ro ports. In fact, in our research, we investigated the digitalization in Ro-Ro sector and Ro-Ro ports. In Ro-Ro ports, a lot of processes are independent. So we have a separate process, so it's quite difficult to create a digitalization approach for this separate, this independent process. Moreover, digitalization integration between ports and operator is still still lacking, because a lot of ports tend to not exchange, do not sharing the operational.
Non stanno vedendo la presentazione, no, l'ho visto adesso, quindi.
Opla. There is some problem on YouTube channel.
Wait a second, I'm
Yeah.
sorry. Andiamo così. No. Scusate,
No.
facciamo. Adesso si dovrebbe vedere.
Vediamo.
Ok,
torniamo indietro di una, giusto di una. Ok. One of the characteristic aspect of the digitalization in Ro-Ro terminals that this port tends not to exchange, to share the operational data with others, because they consider this data crucial for their business, and so they create a barrier to exchange and to share this data. With our proposal in our research, we propose create a sharing environment that connect several RORO ports, finalized to exchange operational information in a simple and secure way. I mentioned some barriers finalized to stop at the increase of digitalization in rural sector. First of all, the lack of systemic vision. Each port think only our business and not have a large vision. The second is the recruitance of some operator to share information, and also the different level of digital maturity achieved by the different actor also in the same port. So it's very difficult to create a digital environment finalized to share information also in a single port. So we propose a structure, a modular structure connected through a not physical connector named EasyLog. EasyLog is a structure where there are a single, a local modular structure that is independent and autonomous for the other. So we don't have a platform, a big platform that collect all the ports, but is the single port. Each port have has the own digital platform. This platform is connected with the other platform or the other port, not using hardware element, but only a connector. And for us, the connector is a set of rules and data exchange. So no a physical connection, no a physical element, but only a set of rule. So in this way, it's possible to use the ICT system already present used in the port. It's possible to add new port. It's possible to use each type of software standard because this connector is open and extensible, and so on. Which data we share? The data are we measure that the number, the type of truck that pass in a particular gate. So we collect the place of detection, the license plate, the nationality and actual license plate, and the date and time of passage. This minimum set is the unique key to identify the EasyLog data. I show you just how these points are equipped. We define two different solutions. One solution is a traditional solution. We use a traditional portal, as you can see in the first picture on the right corner, typical of gate, RORO or port gates with cameras, illuminators, and bars, and so on. The second solution is more light, more easy to adopt, because we create a virtual gates using smart glasses for augmented reality. No portal, no infrastructural element, but only an operator that use these smart glasses to see and to collect the data regarding plates, for example, regarding data and a time of the the passage of the track, so it's easier to create these virtual gates in the port with a minimum cost. So Patrizia show you the result of this research.
Okay, thank you, Gianfranco. I will talk about the experimentation of the EasyLog system. The experimentation was carried out last May, so a few months ago. It lasted 2 weeks, 15 days. And our experimentation was carried out in the 5 ports involved by the project. So in the ports of Savona, Portoferraio, and Olbia, we tested the EasyLog system in case of virtual automation, so testing the virtual gates operated through smart classes, while in the ports of Livorno and Bastia, we tested the hard automation, so traditional automation. One important thing to say about our experimentation is that in our experimentation, we consider the whole maritime corridors between ports of origin and ports of destination. This was really important in order to have a complete monitoring of the maritime chain. Next, okay, thank you. So what we wanted to assess through our experimentation? Through our experimentation, we wanted to test the effectiveness of the EasyLog system for the purpose of its operational feasibility. So we wanted to test the effectiveness of the functionalities of EasyLog developed for Ro-Ro traffic. We wanted to test the effectiveness of the EasyLog connector to exchange data, mainly embarkation list between the ports in the network. We want to assess the effectiveness of the virtual gates operated through smart glasses to be used to manage port operation, especially gate in, gate out operation. And then we want to assess in 2 ports, for example, Livorno, which were already equipped with advanced port community system, the interoperability of the EasyLog system with any IT system already in place. Our experimentation was performed in two phases. We had a preliminary phase of virtual testing. This phase was performed in a laboratory environment where we simulated virtually the 5 port nodes, and then we simulated virtually data acquisition in the 5 ports and data sharing between the ports in the network. Then we had a second phase of real-world testing. This real-world testing was performed in situ, so in the 5 Ro-Ro ports, involving real tasks, involving real operators. So in our real-world testing took part real shippers, tracking companies, terminal operators, and port security operators. In our paper, we have described in detail our experimentation, but I like to talk to you about the Livorno-Olbia corridor, because this is an interesting case example, because it connects 2 ports that are very different from the point of view of automation, because on one side of the corridor, we have the port of Livorno. Livorno is an highly automated port. It is already equipped with an advanced port community system. It has an advanced port monitoring system and also an advanced gate transit security system. While on the other side of the corridor, there is the port of Olbia. Olbia is a not automated port. So with EasyLog, we introduce automation in the port of Olbia by implementing our virtual gate operated through smart glasses. So with our experimentation along the Livorno-Olbia corridor, we tested the effectiveness of the EasyLog functionality developed for Ro-Ro traffic, the interoperability. Sorry for these problems, I can continue. So we test the interoperability in the Porto Livorno with the EasyLog system with the port community system already in place. And of course, we test the effectiveness of the EasyLog connector to exchange operational data between the two ports. In this slide and also in the next one, we have reported a very schematic description of all the tasks and all the actors involved in the experimentation of the EasyLog system, the port of Livorno in this slide, and then the port of Olbia in the next one. We don't have enough time to describe in detail all these tasks, but the important thing to say is that in our experimentation, we cover the entire logistic process from the moment a transporter booked access to the Port of Livorno to embark a RoRo unit with destination Olbia, until the moment the same RoRo unit arrived in Olbia, was disembarked, then made available for withdrawal by another transporter. Okay. What about the results of our experimentation? We can say that the results were quite positive, quite encouraging because the EasyLog connector was found really effective to exchange operational data between the ports in the network. And we had also very positive results regarding the effectiveness, the potential of the virtual gates operated through smart glasses to manage port operation. In particular, during our experimentation, the virtual gates were found effective for correctly reading and recognizing vehicle license plates, and even with vehicles moving up to an average speed of 30 kilometers per hour. And they were also able to correctly reading license plates, even with perspective angles of 40 degrees. We had also the opportunity during our experimentation to test the system in critical lighting and weather conditions. In particular, we had several days of really bad weather when we tested the system in the Port of Olbia. And the EasyLog system did not undergo significant variations in change when weather conditions changed. So this is really, really positive. Of course, we are also well aware that there are this experimentation has several limitations, because these limitations are mainly related to the limited number of tests we have carried out so far, to the limited duration of the experimentation. So the limited number of tests at the moment do not allow us to provide a quantitative statistical evaluation of the reliability of the system, but we are already planning a broader experimental campaign in order to evaluate the system effectiveness from a more statistical quantitative perspective. This will require also assessing several quantitative performance indicators. Just to conclude, we can say that in our opinion, so the positive results of the experimentation concerning the EasyLog system, concerning the effectiveness of the innovative virtual gates, paved the way for the future extension of the scope of application of the EasyLog. We are planning to enlarge the EasyLog network by including additional logistics nodes, for example, interports, because this will be essential in order to guarantee a more complete monitoring of the whole logistic chain, so not only along the maritime leg. And we are also planning to investigate the application of blockchain technology to facilitate the development of an interport community, but I won't say nothing more about this, because this will be discussed in the second presentation. So thank you very much for your attention. If there are any quick questions, Gianfranco and I will be happy to answer. No question? No. So let's move on quick to the second presentation. The second presentation was actually also partially developed in the framework of the EasyLog project. I give the floor to Ludovica Marchesi, who will be presenting Can the Blockchain Facilitate the Development of an Interport Community? Ludovica, the floor is yours.
Thank you, Patrizia. Can you see the presentation?
Yes.
Okay. So, good morning, everyone. My name is Ludovica Marchesi, and I'm a PhD student of the University of Cagliari. Today, I'm going to show you work resulting from the collaboration between the Department of Civil, Environment, Engineering and Architecture and the Department of Mathematics and Computer Science of the University of Cagliari, entitled Can the Blockchain Facilitate the Development of an Interport Community? So, the purpose of this paper is exploring the application prospects and implication of the use of blockchain technology for the establishment of an interport community within which different ports organized in a network can exchange information and data in a secure and effective way. With the support of SWOT analysis, we analyze the application prospect to exploit the advantages of blockchain to facilitate the secure exchange of information between the ports and the parties involved in an interport logistic chain. So, as supply chain becomes increasingly integrated and connected, it is essential to ensure the connectivity of stakeholders, not only with the single port, but also between the various nodes of the transport network. The research questions that guided our research are the following. So, can the blockchain facilitate the development of an integrated port community? Which logistic activities in an interport community would be most impacted by blockchain and in which way? What parties involved in a port community would benefit the most from blockchain? And what are the pros and cons of introducing blockchain in a port community? In order to answer to this question, I will firstly introduce the concept of blockchain and smart contract. So the blockchain is a digital, decentralized and distributed ledger shared and agree on a peer-to-peer network where transactions are recorded and added in a chronological order with the aim of creating permanent and tamper-proof records. Whatever the section of application, blockchain allows for more secure tracking of all types of transaction, from money transaction, data transaction, information transaction, and so on, reducing delays, additional costs, and human errors. In the context of shipping, it is potentially a solution to the problem of distrust among players. Among its main properties, there are distribution that gives resilience and security, disintermediation, so there is no central authority, transparency, all transactions are public, immutability, once a transaction has been sent and accepted, so added to the blockchain, it cannot be cancelled or even modified. Security, which is ensured by different cryptographic mechanisms, notarial storage, and programmability. In fact, complex action can be programmed and executed by on-chain software, which is called the smart contract. So this leads me to the second key concept, that is that of smart contract. So, as just mentioned, a smart contract is a real program running on the blockchain. It can, oh, sorry. Scusate, sorry. Okay, so it's a real program running on a blockchain. It can be seen as an automated contract in which participants prove their identity and approve the contract with their private key. Through a smart contract, it is possible to transfer cryptocurrency, activate other contracts, record information, or connect to external systems. So now I will present the SWOT analysis. And let's start from the strengths. In ports, it is important that companies in the supply chain can trust each other to share information and increase efficiency in shared processes. A major obstacle to data sharing is that a leakage in sensitive information can affect companies' business. So the blockchain provides a trusted and unforgeable corpus of data records that can help in clearly identify responsibilities and source of damages, delays, misconducts, errors, and other aspects. Another strength is security. In fact, records stored in the blockchain are secure since the double encryption mechanism is in place, but also transparency. Shipping companies typically keep their data reserved and secret in order to keep a competitive advantage over their competitors. On the other hand, they can benefit from data sharing for planning in advance, for monitoring, and for coordinating operations. So recording data on the blockchain directly provides transparency and renders information immediately available to authorized actors. This can be especially useful when the information needs to be updated and quickly broadcast to all the actors involved. From the property of the blockchain, once data are loaded into the blockchain, they cannot be manipulated or altered in any way. This can also be a benefit for historical data and for retrospective analysis. Finally, given that all writing operations on blockchain are managed through blockchain addresses which can operate only using the associated private key, all operations can directly be reconducted to the address owners, thus providing a transparent built-in mechanism for managing identities. So now let's see the weaknesses that arise from our study. Firstly, there is an insecurity about the governance of the system. So the missing of a central authority can be an advantage, but also a problem. Another weakness is that blockchain technology at the moment suffers from scalability and performance problem. So in the view of a large interport community, the number of actors and operation in short time can become critical. And also the adoption of blockchain can be difficult. So implementing this technology on a very large scale would require a great deal of computing power. And also because different companies' database may use different standards or even languages to store data, interaction may prove difficult. Another advantage that can also be seen as a weakness is that blockchain provides redundancy. So this is good for security, transparency, and trust, but can be seen as a waste of resource. Finally, in the framework of the European GDPR, all sensitive data pertaining to private and companies must be treated according to a strict regulation. I recall you that all data recorded on the ledger cannot be removed or cancelled anymore once it is added. So this means that a specific strategy must be adopted from the very beginning to decide and plan what data must be recorded on chain and what data must be kept off chain. Now, let's dig into the opportunities. For its intrinsic characteristic, the blockchain is the ideal technology for traceability and supply chain, allowing the creation of unique and shared information which can be accessed in real time and with lower transaction costs. It also allows disintermediation. Currently, many of the port logistic transactions are carried out by email or even telephone calls. There are several intermediaries involved, with the consequent increases in cost, possible human errors, and delays. So the blockchain and the smart contract promise an increase in efficiency, a reduction in brokerage costs, and greater neutrality in the regulation of contract. Another interesting opportunity is coordination. Currently, each freight operator has its own management platform and dataset with limited interconnection capacities. So the information is dispersed. With blockchain, the information is reliably shared. And this would foster interoperability, efficiency, and productivity. Furthermore, it allows worldwide interaction. Last but not least, all the opportunities discussed so far imply cost reductions. Now, finally, let's see the threats in this context. Since all nodes contain a complete copy of the ledger, and there is no central authority to contact in the event of an obvious security breach, privacy can be reduced. One solution could be a platform that will combine a blockchain with an off-chain storage solution. Another threat is the lack in the normative and the regulation for blockchain and on the legal recognition of smart contract. This lack creates insecurity because in the future they could become upregulated or even considered illegal. Finally, when dealing with massive documents, due to space constraints or costs, the typical pattern again is to store them off-chain and to upload on-chain only their hashes and a pointer to the external storage location. This does not grant that the external storage has the same properties that the blockchain has. And eventually, the external storage can be dismissed over time. So in this case, only the metadata related to the document can be retrieved, but not the document themselves. So again, when planning to use off-chain storage, this aspect must be considered. Concluding, to answer the initial research questions, and based on the consideration made, it can be said that blockchain has a considerable potential to facilitate the development of an integrated cross-border report community. All the players may benefit from the use of blockchain, from the terminal operators to shipping companies, the haulers, and even the port authorities. And these benefits may mainly include the reduction of cost, reduction of errors and delays, while increasing of efficiency and collaboration. And thanks for the attention. If you have any question, I'll be glad to answer.
Thank you very much, Ludovica, for your presentation. Very clear. Thank you also for being on time. Let's see if there is a small question. No? Okay, no. I just want to say that, as Ludovica said, this is a very an exploratory study, but we are already working on the development of a kind of proof of concept. So hopefully next year we'll be able to talk about the application of our application. Thank you. Thank you, Ludovica. So let's move on to the third presentation. The third presentation is by Giuseppe Borruso, University of Trieste, Ginevra Balletto, Alessandra Milesi, and Mara Laudu from University of Cagliari. Giuseppe Borruso will be presenting cartography and security for security, trends, and perspectives. Giuseppe, the floor is yours.
Quindi io devo praticare. Sì, questa qua. Non si blocchi tutto, non ti è crashato.
La sento.
Okay, good morning, everybody. Thank you, Patrizia, for introducing me, for the hospitality here in Cagliari. Let's see if the presentation is visible.
Well, we have just a little delay due to technical issues. We'll resume in a minute.
Okay, so thank you again for the hospitality. So the presentation that I'm going to present today is work done with the colleagues from the University of Cagliari, Ginevra Valletto, Alessandro Milesi, and Maraladu, and it is the continuation of a former project of a former cross-border project, Italy-Slovenia Interreg project, related to port security, actually. What we have done here, what we have been going on in this project is actually quite tightly related with elements that we have seen so far during this session, because we actually focused on ICT, information and communication technology, and particularly geographical information technologies related to the issues of port security. We started from the background that is actually related to the relation between city and port in Trieste area in northeast of Italy, and the main topic tackled refer to the relation of these two environments, to the urban and port environment, and the issues that can be related actually to security. Within the wider project we were involved in, we actually decided to focus on some aspects related to the backbone of the security aspect that can be related to ports and its relation to cities. That is actually that of helping in implementing the geographical databases that the Port Authority has already, but not completely systematized, and also to propose some elements related to the implementation of virtual and augmented reality, particularly for addressing visual aspects related to ports. Here, from this slide, you can observe the specific location of the port of Trieste, and particularly the areas, as you can observe, portrayed in blue, yellow, and orange, that refer to port activities. Blue are the old port of Trieste still operating and earmarked for development. In orange, it is the wider part, the wider part of the industrial and commercial part of the port, and in yellow, the part that is actually shared by the Port Authority and the municipality of Trieste. The main idea is that the overlay of these of the different functions can also help in addressing in finding also problems in the combination of the different functions. This picture taken from a photographer friend actually portrays the main part of the harbor, the old port with all the part earmarked for enforcement, the front line of the waterfront with the cruise terminal, the ro-ro and container terminals, the oil terminal, and the brand new logistic platform that is actually that is a few months old actually, and it is hosting a multi-purpose traffic, particularly in this period of time. The second project that is the starting point for this kind of activity, particularly involved institutional cooperation on port security between different actors. What we actually carried out in this program was to put together the different aspects related to the the different partners that were involved. In particular, we had this project in which we had the Port Authority of Trieste and Koper in Slovenia and on the other side of the border, so just a few kilometers far from Trieste. The two universities, Primorska and University of Trieste, and also the Port of Venice. Different ports actually shared what are the main elements, the main topic they were focusing on related to security, from the use of drones to the use of smart cameras and control to the different access to the Port Authority. But here, without going through all the project that has been implemented, I would like to give a short flavor of the different aspects where we focused very much. That is the part related to putting together the port regulatory plan from the digital point of view, in which the digital aspects were actually observed in terms of the expansions of the port, and putting together all the data related, geographical data related to bathymetries that are actually needed to understand how actually ship can shore to the port. And as Trieste is quite known in Italy as a rail port, an important part dealt also with the precise location, precise decoration of the different rail tracks that are actually in the port area, and that, as you can observe, that connect the main docks, the main piers related to the ro-ro traffic and the container terminals. On top of that, we actually implemented, together with a company, an American company, an Italian origin American company, focused particularly on visual storytelling, as they used to advertise themselves, but experimenting immersive media, particularly virtual tours, virtual reality, and augmented reality, and to provide a kind of, let's call it, situational awareness of what is the port areas, the facilities. In particular, we implemented a digital framework based on the SICBIG platform that has been acquired also by our laboratory, and we did implement a first test during this project on two main points, that is the logistic platform. As you can observe here from the previous image, it was still in construction when we portrayed this analysis, and the new free zone, a kind of dry port in the inner part of the city of Trieste, and also experimenting, let's see if it is visible, but in internal buildings, a kind of a 3D view of internal. I want to move a little bit to the visual part of the project that we did implement. That was a set of let's see if it helps moving, of the new Trieste, of the dry port that actually is acting as a warehouse and also as an internal logistic platform for the port of Trieste. And the other example, that is the logistic platform. As you can observe here, it was still in construction. Now it is actually operational, and here this old Google Maps, Google satellite picture is actually showing you how it was during the construction work, and here you can observe during the survey that we had actually how the platform has been built to host today ro-ro trailers and containers. And let me go. And but from that, as you did observe, dealt with the survey of different points within the same platform. We went on in there is a little delay, and I do apologize for that. Okay, we went on in implementing the 360 degrees picture to the whole city of Trieste, with a focus that we had on the sea, of course. And this is a kind of survey that we started this summer, actually, showing us some locations within the city of Trieste, both on the urban side, but also we took the opportunity of a short tour that we had and observing the cruise terminal that as you can observe, it is on the waterfront of the city of Trieste, and the other port facilities. As we move to another of the pictures, like the container terminal, as you can observe it here, and with a view also on the Roro ferry, the multi-purpose ferry. So this is I conclude this presentation with these pictures, and this is not a conclusion actually, but it is a kind of new starting point for a development of the of something that we started in the project. The idea is trying to put together this kind of static set of images and pictures with a more dynamic set of information that can be also tagged, because what is not presented here is that these pictures can be tagged with other the multimedia information coming from other sources, and therefore it can be coupled with other databases that belong to the Port Authority or related to other ships or items that can be also retrieved via the web. So this is actually what we are starting to implement in the following months and the following evolution of the project. Okay, for now I stop it. I think I'm over with my time.
Thank you very much, Giuseppe, for your presentation. Let's see if there are any questions. No? Okay, so since we are a bit late with respect to the schedule of the session, I will go to the fourth and last presentation of this session. The last presentation is by Luca Braidotti, University of Trieste, Marco Mazzarino, University of Venice, Giuseppe Borruso, University of Trieste, and Giuseppe Borruso will be presenting again. This time, the study is a review of best practices to reduce the environmental footprint of port areas in the Adriatic region. The floor is yours, Giuseppe.
Good morning again. I will be sharing again my screen, and let's see if it works. Dividendo. Okay, so again, this is the result of another European project, another research project between Italy and Russia. In this case, it has been particularly developed by the colleagues Luca Braidotti and Marco Mazzarino, and it actually was based here again on a set of best practices coming from different ports and different partners involved in the project, particularly with the other important point as the environmental sustainability. The project's Southport in particular was based on analyzing this set of practices, not just related to the ports of the study area, that is the North Adriatic region of Italy and Croatia, but also observing what is going on, what has been developed and implemented in other ports, in other realities.
The SOSPOR project was based on a best practice analysis that involved all the partners and territorial needs assessment, involving particularly all the port authorities, particularly related with, of course, with the particularly relevant topic today, that is that of port emissions from the sources. We do know that this issue is quite important, and in the environmental evaluation that are done at port level, the balances related to emissions tells us that 90% of the emissions in port are generally coming from ships. So that is one of the main points to be tackled in the future evolutions in terms of the issue related to decarbonization. Here you can observe the results of the best practice analysis in terms of the ports involved. We can observe that both Adriatic port on the two different sites were analyzed, but also other areas, other important international European ports like Hamburg, Rotterdam, Amsterdam, and Antwerp. And of course, what we did found was that, of course, different ports have to face different kind of needs and issues related to the from the environmental point of view, and of course we can observe a different level of evolution between the different ports from the Northern European one and the Mediterranean ones. The former, of course, are historically more careful, put a larger care to environmental issues, and as a matter of example, they are already working on important aspects like cold ironing, that is also something that Italian ports are fostering in many cases, and the installation of several systems for renewable energy. For example, just to name a few, Port of Ancona is one of the ports that actually it is working on several aspects, like reusing from a building and gaining a major environmental awareness. The Port of Antwerp is also very much involved in energy optimization and the use of renewable energies and so on, without going into too much detail of every port involved. Cold ironing also with the Port of Genoa. We must say that several actions are actually ongoing in different Italian ports, in particular related to the decarbonization, and we do know that actions like cold ironing or using alternative energies for giving energy to ships, another system, it is actually something that is ongoing into the Italian framework, particularly as it will be done in the following months after the new plans just implemented. Okay, so this again, what we did find, what was found in this project as well was the fact that again, different ports face actually different needs in terms of environmental sustainability, with policy aimed at, in any case, fostering the emission aspects, the energy provision for the different systems, and again, it can be a further step to try to find different kind of best practices at European level. Okay, I stop here, but I think that we are quite over in time, and I thank you for your attention.
Okay. Thank you very much, Giuseppe, for this interesting presentation. I think it will be really useful to have a sort of monitoring system of environmental initiatives implemented by ports. I don't see questions. No. So our session is over. Thank you, the presenters. Thank you very much, everyone, for joining us. I invite you to join now the third and last session of the Smart Ports workshop that will start in a few minutes.
Yeah, there will be a 15 minutes break.
Okay.
So we will resume at 11:30 European time.
Okay.
Thank you all for your cooperation. See you later.
Goodbye.
I'm one of the presenters for the next session. Can I try my screen sharing and mic for now?
Yes, go ahead and try. We can hear you, so you can try to share your screen if you
Yes.
want.
Can you hear me clearly?
Okay, it's working. Perfect.
Yeah. Thank you. So I can
Yeah,
change.
it's working properly. So we can. Okay.
Thank you.
Dear colleagues, good afternoon.
Good afternoon.
I have to start. Is it any stakeholder here?
Hello, sir. I am the assistant, and we are waiting for the chair, who is actually at the moment out of the room, and then we can start. Just
Okay.
a few minutes of patience, and then we are ready. Thank you for your patience.
Yeah.
In the meantime, yes, you can try and see if
So
this is working.
let's
Yes, we
see.
can see your presentation.
So is it okay? Did you see presentation? No problem. No any problem. Does it work?
Yep, it works perfectly. And perfect. So we'll resume as soon as we are ready, and just a minute. Okay, good morning. Morning, everybody. We are going to start the session SmartPort 3. I think the last one of the SmartPort workshop within this conference, within ICCSA conference. I would ask you to wait for a couple of minutes that some other colleagues are coming along in presence, because here in Cagliari we have some colleagues that already presented a few minutes ago in SmartPort 2 and SmartPort 1, so I would ask you a couple of minutes more of patience before we start. I ask particularly the first presenter scheduled, Professor Vladimir Shakov, that agreed and thank for being here today. So I thank Andrea Piano for the support today. Okay, so we have scheduled 4 presentations today, this morning. The first one that we will see in a couple of minutes, towards edge computing-based monitoring for smart ports. Second presentation scheduled, it is teaching English word order with corrective writing software, multi-agent based adaptive e-learning system, and university web environment readiness for online learning during COVID-19 pandemics, case of financial university. Yes, we are actually merging different sessions today, so smart ports plus AWBL. So it is one of the charters of ICCSA conference is the contamination of different branches of computer science, and so this cross-fertilization, it is also one of the main points of the main of the main advantages of this conference. Okay, so I think that we can start. So I stop myself talking, and please, Professor Shakov, when you feel that you're ready, you can start and present your paper, your work.
Okay, thank you. Dear colleagues, good morning, good afternoon, good evening, and probably good night. I'm Vladimir Shakov. I'm associate professor of Novosibirsk State Technical University. Also, I'm a senior researcher of Institute of Computational Mathematics and Mathematical Geophysics. My advisor Anastasia, also from this institute. We are focused on investigation problem related to some long infrastructural objects, and we can find a lot of the mentioned object in sea and river ports. So ports constitute an important economic activity, being an important interface in the supply chain between sea and land. Their role is only grows, as you can see. Port now faces increasing pressure to optimize their operations and provide more cost-effective and safer shipping. There is a growing global trend towards the needs to implement new technological solutions to facilitate the transformation of conventional ports into high-performance port to support the increasing import and export tonnage and associated cargo traffic, while reducing potential environmental and health impacts and vulnerabilities to extreme nature disaster and man-made disaster. The port industry is undergoing a transformation to smart port and the result of technological advances and the changing customer expectations. A concept of smart port and also of a variety of advanced digital technological consisting of monitoring, control, automation, intelligence, equipment, and so on. I need to remark that no generally accepted definition of smart port has been provided. Anyway, it is expected that the world trade system will be different as we know it today. And also, the exact future of global ports and shipping industry is still uncertain. It is important for industry shareholders to consider this trend and to prepare with appropriate policies and strategies. In some very general sense, a smart port is a port that uses automation and innovation technology like artificial intelligence, big data, Internet of Things, and blockchain to improve its performance. So this is some kind of very maybe abstract and very general definition of smart port. So we will follow this one. And if we say about IoT technologies for monitoring some infrastructure, generally we mean wireless sensor networks. So wireless sensor networks is an important part of IoT. And there are several projects on and standardization initiatives for wireless sensor networks, which may eventually converge with Internet of Things. As example, I can remember a European Union project of Internet of Things architecture, and the same project like Sensei. Those projects have addressed some challenges of IoT solutions development from wireless sensor networks perspective. So just bring result and solution achievements in the area of wireless sensor networks to IoT technological rhetoric. And application of thinking system in port reach, and this is some example. This is a paper with a good survey of sensing technology application in seaport area. Sensing system important tasks such as structural health monitoring, container position detection and handling, and AGV localization, automatic guided vehicle locations, navigations, control, and so on. And wireless sensing network-based technologies allow to get smart sensing architectures for container identification, management, vehicle management, on optimization, maybe traffic optimization, various location, navigation services, and safety of port terminals equipment related to structural health monitoring, and of course, ecological monitoring, air quality condition, and maybe some kind of of water near the port and so on. And in recent investigations, papers, researchers have known that the following topical challenges that wireless sensing networks face in smart ports. Special features of wireless sensing networks make it particularly challenging to provide reliable services. The traditional approaches for reliability and security, quality of service support is expected to fail. And moreover, the port environment is unfavorable for wireless communication. The signal can be shadowed, reflected, scattered, and so on. This results in data packet corruptions and degrade network performance is also degraded. And overall, wireless technology are prone to be affected by big metal parts, which we can meet this one in the any ports, high power electric appliance, and so on. To take this issue, some anti-noise, anti-jamming technique approaches have to be applied. So if we consider some monitor, exactly if we focus on some monitoring of a long object in the port, we can generally use some structure known as linear wireless sensor networks. So especially if we consider monitoring of PP lines. For example, port of Rotterdam has very large of networks, and generally it need to be monitored in order, for example, to detect and some leakage and predict some leakage. So if we use some, generally we can use some machine learning technique, and I know some projects related to this one to not only predict, but also not only detect, but also predict some problems like leakage. And in case of oil and gas pipeline, in this case, if we use this one, then we can prevent catastrophic disaster, monumental disaster. So, and as far as I know, a lot of ports connected with the pipelines, with some related areas. So it seems some kind of important thing to provide monitoring for this type of pipelines, and generally structure of monitoring system is linear, quite linear. So, I mean, linear means topology of networks is a simple chain, or something like this, like trees and maybe stars and so on. So, what are the, if we just summarize some kind of steps we can do to improve somehow improve wireless sensor networks in smart ports. We need to keep in mind that wireless channel is unreliable, and also sensor collect and transmit huge amounts of data in real time. So the market requirements is quite hard, so sensor have to be cheaper, and it means battery capacity is also limited. So the problem of energy consumption is also kind of large issue. And to deal with this, we can use the paradigm of edge computing. This is some trend in IoT area, edge computing. The paradigm of edge computing, where data is processed close to its source, alleviates the problem of transferring and storing huge amount of data. If sensor is smart enough, then the sensor can analyze data, make decision, and transmit only final result to port operators in very compact form. So the problem is to optimize the transmission of computer solution, take into account some trade-off between cost and reliability. So we need to first find some kind of lightweight because generally resource of IoT devices and sensors are limited. So we cannot use, for example, some kind of convolutional neural networks, and we need to use something like SVM in our. So first we need to somehow define the machine learning approach, which can be used in device to get some solution and treat data in the sensor. And next, we have to think how to improve reliability of final decision transmission. Because if we transmit a lot of raw data, then decision sensor can use some heavy computational techniques and reduce outlines and maybe some correct data and so on. So if we transmit a huge amount of data, then it's not so important to think about reliability of some kind of single packets. But if we provide final decision, this is actually a result of operations, then in this case we need to think and maybe use some increased packet size, so to provide reliability of these transmissions. In case of in our point of view, we think that nearest neighbor is a good technique for implementing a device for this type of sensor, because generally, at least our experience demonstrate that we can easily situation is very clear for these areas, right? So if we for example, this is a 2 parameters. Generally, we can know a lot of parameters the sensor can collect, and there are some kind of bounds. So if, for example, vibration is higher than something or wind higher than something, then definitely problem. It's clear decision. So we do not need to use some probabilistic approach to get some kind of optimal conclusions. It's clear. And also in some ellipse near 0, also clear situation. So no problem. So we use simple rules, but for example, on Minkowski distance, we definitely with probability 1 absolutely reliable, provide absolutely reliable decision about situation, and generate alert, or maybe just do not generate rate. So we need to use some kind of machine learning technique only for intermediate layer, and in this case we can use same procedures as we use for nearest neighbors for decision rules, deterministic decision rules. So this way is to optimize some software and provide some kind of lightweights for machine learning. And next, generally system is topology is linear, so we need to. This is a quite unreliable topology. So anyway, we need to think how to improve and get trade-off between reliability of transmitted message and between energy consumptions. And the most quantity of energy sensors spent for data transmissions. So if the good way to improve efficiency to implement some technique, if we can do this to make data reparation, so restore data if possible. So use noise correcting some kind of approaches for this one. So we consider some simple models. Assume that final decision is transmitted as packets or messages with n bit lengths. So this is some sensor report, and the probability of error of single bit is p, and we assume that redundant noise correcting code is used, and then that code is capable of correcting up to key errors. For example, if we use Hamming error correction Hamming code, then double error correction Hamming code, then key equals true. For these assumptions, we get some formulas. Formulas provide us reliability of transmissions if we restore data in intermediate node and if we restore data in only in sync. So intermediate not only transmit data without any restorations. And then
sorry, we should try to go towards the conclusions because we are quite running late. Thank you.
Yeah. So and if we use additional thing, so we just make some cycle. In this case, we also get some formulas, and these formulas allow us to get some performance analysis for different type of systems and generate requirements for hardware and for protocols. And the situation is quite unknown, so you can see in case of reliability, this is definitely better to use intermediate treatment of packets. But if we think about energy, so profitability, then the situation is unclear. Finally, I would think that and mention that this is one of the tasks we solve within a project of Russian Fund of Voluntary Research and China's national funds with colleagues from China University of Petroleum. Thank you for the attention. If any question, I will be glad to provide the response. Thank you.
Okay, thank you very much for this interesting presentation. It is well in line with the topic that we have tackled so far during this smart port session. So I think that there is room for there will be room for evolution of this session towards maybe special issues. So please stay tuned, because we are planning to implement some special issue after the conference, where evolution of the paper hereby presented could be hosted in another set of publications. So thank you again for your presentation.
Yeah,
Okay.
thank you.
Thank you. Okay, so now we move to the second presentation, teaching English word order with the correct writing software. Now we are moving far from smart ports, actually going towards the AWBL conference, I think. So if there is somebody, I think I can spot Mr. Oleg Sicher here as one of the names that I see in the list of the potential presenters today. I don't know if you are ready for. Okay, you're ready for presentation. Okay, thank you. You can start your presentation whenever you prefer. Thank you very much.
Thank you. Can you see my slides? And here.
Also visible.
Yeah. So, my dear colleagues, my talk today will be about our experience and using correct writing questions in Moodle learning management systems for teaching the problem of word order in English sentences. The motivation of our research was the increasing using of online courses, especially during the challenge of COVID lockdown, creating responsive and flexible adaptive education programs and assessments that can provide students with feedback right as they train, so that we can close the feedback loop without the teacher and let students learn on their own. Correct writing questions were originally developed for Moodle LMS and designed for teaching formal and natural languages where the order of tokens or lexemes is important. English is one example of such natural languages. In short, correct writing questions support entering open text, open answer, short text answers, and they analyze teachers' answer, breaking them into lexemes, idea words, punctuation marks, and so on. And each token or lexeme is given a special description by the teacher that responds to its role in the sentence, and so determines its correct place that can be used by the system to generate feedback. When the student gives a wrong answer, correct writing can detect 4 kinds of mistakes. It can find typos and typos including skipped or unnecessary delimiters like spaces between 2 lexemes. It can detect misplaced lexeme, the most basic mistakes in the word order, when the word is placed somewhere else. An extraneous lexeme like a wrong word or an additional word, and omitted lexeme, that something is missing. And you can see that in the mistake messages, the original word is not disclosed, but its description is used instead. So the mistake messages stimulates the students to think what is the verb in these systems and where the verb should be placed in a sentence. This is important for teaching and to not just make, oh, this word is wrong, but to think about the grammatical role of those words. For the students who have problems with modifying their answers, there are a number of hints that they could use. What is hints? Says what is this, the word in this sentence. idiots. So you can see in this sentence the verb is been, if this is understood. Where to place textual hints generates a sentence telling where to place using the description of the words before and after the given words. And the last image, where to place hint, shows how to modify the sentence to get it right and to fix this mistake. It can display many mistakes in a single sentence. In order to use it in actual course, we created a set of quizzes using correct writing questions. Summative quizzes had hints disabled, were held limited times under teacher supervision, and allowed only one attempt of answering in questions, while formative quizzes were created for free use by the students during their preparation time and homework, and they allowed hints, unlimited time to answer questions, and unlimited attempts to answer questions using. The goal was letting the student using hints until they find the correct answer and learn from it. We created quizzes over 9 general topics, including statements, negative sentences, and different kinds of questions corresponding to the main topics in teaching English word order. In our experiments, 45 students took part and did all the series of quizzes, starting from the summative quiz to measure baseline performance. Then they did a number of formative quizzes as much as they wanted, and the second summative quiz to measure and grade their final performance. So we divided those students into 2 groups. Computer science students were undergraduate students, and chemical engineering were graduate students. Their baseline performance was up to 4 points out of 10, and we can see that it varied differently. What can we see? For undergraduate students, the best performing student chooses to not do formative quizzes and ignore correct writing as a training tool, while the lesser performing student using them. For graduate chemical engineering students, the worse performing students ignored formative quizzes, while the better performing students did a lot of them. But if we can see, those are average learning gains for the students who did formative quiz attempts, but this is more illustrative. Those are relative learning gains to their baseline grade, because the people who had better baseline grade had less to learn, to gain. We can see that for undergraduate students, the more attempts they did, the better are their learning gains. So we can see that correct writing questions clearly helped them to gain more. There was only one student who did a lot of efforts, 15, and it didn't display it here to not ruin the graphics, but the learning gains were very small. This shows that sometimes those quizzes can be overused and abused, and too much gains nothing. It is a bit more complex for graduate students who can better learn on their own. So the people who didn't use the formative quizzes had average learning gains better than those who did it only a little. But the people who did a significant number of quizzes, 4 or more, had the best learning gains among the graduate students too. And this is even more important because their initial baseline performance was high. So even then they had the best relative gains. We also conducted a short survey about the students. The most of the students find those questions useful and expressed the desire to do more of similar exercises during different topics. Most of them rated their grammar skills improving between 40 and 80%. And the most improved skill were, by the students' opinion, translation skill, because all the questions were tied with translating sentence grammar, because the quizzes taught them what order, and independent work skills, because they were learning without direct teacher supervision. So we can conclude that correct writing questions can be used for teaching word order in English without direct teacher supervision and produce good learning gains. For undergraduate students, those gains generally increase it with the number of the formative quizzes they attempt, while for graduate students, only significant amount of attempts brought good gains. But too many attempts must be restricted, because this leads to misusing and not learning much from any attempts. There is a room for improvement. We also noted some problems with using those quizzes. For example, we must take into account synonyms and possible abbreviations so that the question will accept all correct answers. We also need to develop a unified system of descriptions, share it among teachers so that the lecturers and the quizzes use the same terms, and expand the features of correct writing to detect word formation errors and choosing word form errors. Correct writing question type is released under GPL license and available from the Moodle plugin site. So if any one of you is interested, you can download and use it. Thank you for your attention.
Thank you very much for your presentation. Interesting piece of research, actually. Also good for the Moodle users, as I'm actually am. So I will take note of this useful evolution that you have produced and presented so far. So, is there any question from the people connected, from colleagues and friends connected? Okay, so apparently no questions. Thank you again for your presentation. And now I will move to the third presentation today, second of this sub-session, a multi-agent-based adaptive e-learning system. I don't know if we have, yes, Birol, whenever you want.
Can you hear me?
Yes, we can hear you. Whenever you prefer, you can share your screen and start your presentation if you have a PowerPoint presentation or whatever.
Yes.
Okay, we can see it.
Can you see the presentation?
Yes. You can start whenever you feel ready.
Okay. Okay, thank you. I'm going to present our paper titled Multi-Agent-Based Adaptive E-Learning System. As part of the outline, I'm going to briefly introduce the main idea and then the related work and introduce our system. So in this paper, we proposed a multi-agent-based adaptive e-learning system that supports personalization based on Felder and Silverman learning style model, which is the most commonly used learning style model in the literature. Other than that, we proposed an adaptive e-learning system solution because we wanted to provide more effective learning experiences to the students based on the individual differences of the students in the learning processes of them. So in our system, we also monitor the interaction of the students with the system, with the agents. And we also want to recommend learning materials to them We do this recommendation based on their learning styles and previous knowledge levels. That's the main idea of the paper. For related work, we briefly introduced the multi-agent systems notion, but I'm not going to go into detail here so much. I can say that multi-agent systems are quite good to use in complex problems where multiple agents cooperate on the problem to solve them together collaboratively. And in this regard, multi-agent systems are also used in the e-learning domain. And here are some multi-agent platforms listed that are Jade, JetX, Jack, and Emerald. These are fully FIPA compliant platforms. There are also many other multi-agent systems platforms and languages available in the literature, but those are the top ones based on the FIPA standard. And moving to the e-learning domain, I can say that multi-agent systems are used in the e-learning domain to provide three main functionalities. Those are, categorized based on their actions, their responsibilities. In this regard, we can say that there are pedagogical agents, harvester agents, and monitoring agents. Pedagogical agents are the most common type used in the e-learning systems. We all probably have seen some of them in the e-learning systems that we used, especially considering the pandemic going on. So their main functionality is to guide students during their studies, and they are interactive. So you can see them as an icons, and they interact with the students, and they ask questions, or they provide solutions or hints to students, and they help them.
We lost the connection. We can't hear you anymore, nor see the slides, unfortunately. If you can hear us, just give us a signal in the chat. Eventually.
Dio, can you hear us?
We hope to resume soon, but we have a technical issue for the presentation going on. Let's wait for the presenter to resume with the presentation.
Okay, maybe we have some technical issues with the presentation by Birol Ciciloglu. Okay, so I suggest in the meantime we'll try to contact Birol in these minutes. I think that in order to continue with the okay, she disconnected. Maybe she has some technical issue related to the connection. But okay, so I would ask in the meantime if Birol is not going to connect in the next few seconds, we could move to the final presentation, maybe leave Birol some minutes afterwards. And so
We have one of the other presentations today. It is University Web Environment Readiness for Online Learning during COVID-19 pandemics. I don't know if, okay, we have connected either Mikhail Ivanov and Vladimir Soloviev. So I would ask you if you are ready. Okay, hello.
Hello, dear colleagues. I'm happy to be there and to present our financial university. My colleague will present this presentation. So, and we need only a few seconds
okay, great.
To be ready. Yeah.
Okay.
Thank you very much.
Thank you very much. Okay, great.
Вот. Расшарить вот здесь вот. Так, и вот.
Okay, great. We can see your presentation. So whenever you like, you can start.
Yeah. Thank you. Good day, colleagues. My name is Mikhail Ivanov. I'm one of co-authors of this report. And I want to tell you about University Web Environment Readiness for Online Learning during COVID-19 pandemic. I represented financial university, and of course, I want to tell you about case of financial university. So when we talk about distance technologies implementation into full-time education, we have some questions. First of all, the aim. Aim, of course, to reduce contacts between people. Between teachers and teachers, between students and students, between students and teachers. But we have some questions. There are how to measure the efficiency of distant learning. Are there any relevant methodical developments for organizing such training? Are there technological platforms and technical tools that support the remote educational format? Is it possible to quickly deploy them in sufficient numbers? What are the financial costs of the transition? How long will it take? How long will it take to prepare professors, to prepare students for remote learning? And so on, so on. And one of them also, how can online learners be identified? Of course, we need for fast technological solution. Our main task is quickly ensure the availability of IT infrastructure and the necessary network traffic. Quickly acquire specialized license software for all participants in the educational process. Quickly educate students, quickly educate teachers, quickly ensure the transparency of the class schedule, quickly organize this smooth functioning and interaction of structural units. Several last years, we worked hard on comprehensive digitalization project of the financial university. The project involves the transfer of educational activities to a single technical platform. In fact, during the period of preventing the spread of coronavirus infection in 2020, this project was very relevant. Many stages had to be implemented in a shorter time frame. Some of the subsystems were designed and implemented for changing the business process because of the pandemic. At the same time, the work was carried out in conditions of uncertainty and ahead of the schedule. So in 2020, a number of important components of a unified informational and educational environment were implemented in a modern condition. This slide shows us a unified technological platform of financial university. Unified ERP system with modular architecture is the main part of the technological platform. It's connected with numbers of personal accounts, students' accounts, employees' accounts, graduates, and so on. Of course, unified technological platform has integration with the number of external systems, such as LMS Moodle, proctoring system, Open EDX, anti-plagiarism, and so on and so on. Another feature of 2020 is the holding of classes in remote mode. For students, it is now possible to go to virtual classroom for meetings of such systems as Microsoft Teams or Zoom. And students have ability to viewing the schedule in their personal accounts. In financial university, we use Microsoft Teams. The implementation of control over the educational process is carried out using developed specialized software product. This product located in Microsoft Azure Cloud and using the serverless principle of code and data placement. It allows us to save on the maintenance of the solution, both due to the technological efficiency and due to the elasticity of services. This program code provides interaction with the local services of the university using the API on the part of the Microsoft Teams. The solution interacts with the Microsoft Graph API toolkit with the storage of the intermediate data in a database. We use Cosmos DB for that. The interaction of the United Information and Educational environment of the financial university with the developed logic for the Microsoft Teams system in terms of monitoring the educational process takes place in a constant mode. It provides us real data available on request and without delay. Information about the schedule is sent to the cloud service from the schedule of training session system. Where data is preparing, it means planning and generating a unique Microsoft Teams link to classes. And where data is preparing, and then the information is returned to the schedule system, thereby ensuring the integrity of the data even when they are changed in the schedule systems. This is implemented through change control mechanisms. And using this solution, we get the following data slices. First of all, monitoring of planned and actual values, real-time information about the users present, time, date, event, and etc. Information about violations and absent students, cross-section for any period of time, about any user, about any divisions, data segmentation using filters, and so on. And at the end of my presentation, I want to show you some system screenshots. First of all, real-time attendance control. This is general dashboard. Part of them in Russian. I'm sorry, but I tried to translate. So it's left side. This is the plan value. from schedule, teachers, departments, start time of the meeting of the class, student groups, personal names, students' personal names. And at the right side, fact about lessons, about meetings. There are teachers who organized this meeting, start time of lessons of meeting in Microsoft Teams, end time, and visit list with student names, time start, time end, and group name. The second screenshot about analytics students, analytic about students, top attendance. So in the left side, filter about faculty, about group name, and at the right side, detailization about attendance index. There are not very good students. There are students who didn't attend classes at all, or attend some classes, just some classes. One more screenshot about analytic about teachers, the same analytic, but not about students, but about teachers. And the main analytics about all classes, all lessons, how many lessons were planned and how many classes were held. So you can see that there were about 1,300,000 lessons planned, and 1,000,000 and almost 200 classes were held. So attendance index is very high. It's almost 0.92. So and we have some analytics about technical data, about operation system, about teachers, and about operation for students. So the university has made all decision very quickly and without the right to make mistakes. Of course, new services were deployed, taking into account the possible of new lockdown because pandemic. The results shown by digital transformation departments shows teachers and employees allows us to say that the most of the tasks were successfully solved. So thank you for your attention, and you can ask me some questions.
Okay, thank you very much for your presentation. Very interesting, thorough one. Is there any question from the public, from people listening and attending this session?
I can ask some questions. Maybe we can have an email to each other, because I work on similar problems in our university too. First of all, did you try anything to account for the students who just connected to the lesson, then go away? There is always problem with distant lessons that some of the students simply connect and didn't participate at all.
Yeah, this is a problem when students just connect at the start and disconnect at the end of the classes, but didn't participate. Yeah, sure, it's the problem, but we didn't solve this problem, of course. We just monitoring all activities in the session. I mean connecting and disconnecting, and we can say that this student connected 5 times per one meeting, and connected for 5 minutes at the start and 5 minutes at the end, and the same information about teachers. But activity inside the meeting we can't calculate.
I see. Do you plan to release your system under some license, or do you consider it a property of your university and not for use by other universities?
Of course, it's our program, and but we can discuss it, I think, and I write my email to the chat. Just a second.
Yeah.
I think you can write me. Chat. Yes.
Chat is the next button to the screen sharing.
Yeah.
Okay, so thank you for your presentation and for this good exchange of impressions. As we have got some minutes left, I would ask Birol if she wants to complete her presentation because it was quite dropped at a certain point. So we have some minutes to hear the conclusion. The conclusions about a multi-agent based adaptive e-learning system. So Birol, if you like to share your screen and
thank you so much for this opportunity, and I'm so sorry for the connection loss. I didn't recognize it, and I was presenting to myself all this time.
No worries. These things do happen in this period.
Do you remember where I was at the presentation?
I think that you were actually you dropped down your.
Sorry.
Nice view. Okay, if you go a little bit further, you're more or less in the middle of your presentation.
I think I can briefly summarize our,
if you can, yes,
our proposal. I can skip the
okay.
network and start from here. So in the e-learning system that we proposed, there are two types of agents. Student agents that keep track of the interaction of the students with the system and provide personalized learning material suggestions to the students based on these interactions. And all those information are kept at student models, learner models. So the main idea is to assist students to have an enhanced learning experience. There are also lecturer agent types that have two types of functionalities. They assist the lecturers to provide metadata of their learning materials. And lecturer agents can also reason about the students' interaction level of the system and can detect whether the student is at risk of dropping the course or not. So some of the basic behaviors observed by student agents are time spent on learning materials and mistakes made by students during learning sessions. Student agents are also responsible for recommending learning materials, and if there is a drop, if there's a significant drop at the success level of a student, the agent responsible for this student sends a notification to the lecturer agent, and the lecturer agent further processes this information and decides whether the student is at risk of dropping the course or not. So lecturer agents request metadata from the lecturers for the learning materials that they supply to the e-learning system. And lecturer agents also assist the students by processing the notifications received by the student agents. When we consider both of the functionalities of the agents, we can say that they can be considered as pedagogical agents and monitoring agents. At the related work section, I said that there are three types of agents used in e-learning systems. The third one is the harvester agents. So none of these agents perform harvesting functionality. So they are pedagogical and monitoring agents. Another approach for multi-agent systems usage in e-learning system is the environment modeling approach. And in this regard, student models and learning object repositories can be modeled with artifacts as part of the environment of the agent. But in this study, we didn't use this approach. We decided to focus fully on the agent functionalities and provide intelligent functionalities. That's why we skipped that. Here, you can see the architecture of our proposed system. There are different interfaces for lecturers and students. Each agent type is represented here. They register themselves to directory facilitator agent here. It acts as a yellow pages registry. So agents can register themselves to DF, and then they can communicate with each other directly. And they can also search for agents providing similar functionalities at the DF. And there are also student model layer and learning material layers, which is basically used by each agent type. And now, if we go to the prototype implementation, we can say that we choose a JADE agent development platform for implementation of the prototype because it's fully FIPA compliant, and we have listed them, the fully FIPA compliant agent platforms at the related work section. There are only 4 of them, and JADE is the most widely used one. It's easy to learn, and it's easy to develop systems with it. It's implemented with Java, so it's portable. And it also provides enhanced graphical debugging and deployment tools. And it also supports usage of ontologies. We also used ontologies in our system, so it makes it possible. That's why we choose JADE for the prototype implementation. And for the ontology part, we can say that we used a previous ontology. That is a previous work of ours at this reference, and it uses 3 types of learning style models in it. For this prototype, we utilize a subset of this ontology. We used only one learning style model, Felder and Silverman learning style model. However, we also extended this ontology to store the interaction history of students. Here you can see a remote agent management graphical user interface of the prototype in JADE platform. Here you can see learner 1 agent from learner type and provider 1 agent, which is a lecturer agent. And here you can see a graphical user interface for the lecturer to enter metadata and select the file for the actual learning material and store it at the learning material layer. As a conclusion, I can say that this paper is involved with a prototype implementation, which is developed as part of a project. It's an ongoing project, so implementation is still going on. We can say that at this stage, we have completed addition of learning materials to the system by the lecturer with its metadata, and storage of it at ontologies, student ontologies and learning materials ontologies. And for the learning material recommendation, we used as a previous work of ours as well for the implementation of this. And also as a third functionality, determination of at-risk students is also supported, but it's also supported at an initial level. So we use students which interact with the system at a lower rate than the average. And that's why it's at a preliminary level now, but it can be enhanced. And for the last slide, I can say that this study focuses on proposing a multi-agent system-based architecture by utilizing ontologies for student modeling and developing the first prototype of it. And after the completion of the implementation, we plan to test the effectiveness of the proposed system by using it at a personalized course, which includes personalized course materials. And that's all. Thank you for your attention. I hope I completed on time. And so sorry for the connection loss again. Are there any questions?
Thank you, Viol, for your presentation. Is there any question by people connected?
Well, thank you for your presentation. Actually, it's a kind of work we are also interested in, because we are trying to educate from the different direction. You mentioned that you agents analyzed the kinds of mistakes the students make, and the main problem for such system, as I see it, is automatic determining of those mistakes, classifying them, and so on. Did you rely on the teachers to classify mistakes, or do you use some model?
For this part, I guess your question is involved about this part. Here, the mistakes, we analyze them actually. We do not categorize them. I can say that it's not at an enhanced level yet. What we do is there are certain correct answers for each exercise. So if the student answers the exercise incorrectly, so those are all mistakes, and we store the mistakes made by the students, but we just use it as correct or incorrect right now. We do not analyze the types of mistakes.
I see. If you are interested, we can email each other after the conference. I wrote in chat my email. We are developing some domain models that are devoted to determining the types of mistakes, exactly software laws that are broken by each student's answer. You may be interested in incorporating our models, comparing your models to ours, and so on. If you can write me your email or email me, I can send you the links to our works, and maybe we can think of something.
Yes, it can be useful. I will email you. Thank you.
Thank you.
Okay, so thank you for your presentation, for this interaction, also on the topic presented. I thank all of you for being here today, connected to this session within ICCSA conference. I thank you very much. I think that you can close here this session, and we are also going to terminate this conference, and we hope that next year we'll have also a session in presence and we can meet each other at some point. I thank you very much again, and have a good day. Thank you, and thank you to Andrea Piano for the assistance given today to this session. Bye-bye.
Thank you all.
Thank you. Bye-bye.
Thank you. Bye-bye.
Good luck.
Goodbye. Bye.
Bye.